Hello, my name is ChristineKoehmstedt. I'm presenting this presentation on regression networks for question 3 for the assignment for HAP 823, which is Comparative Effectiveness, taught by Dr. Farrokh Alemi at George Mason University, and this is spring 2025. So to get us started, we'll review the question that we have to answer. So inside an electronic health record, there are data on outcomes of a particular intervention. Using the network, write the equations that would allow you to estimate what would happen if the intervention was not given. First, write an equation for each node in the network based on that variables that precede it and indicate the significant relationships with an asterisk. Second, set the variables that change across these equations to the relevant values. So example, set the treatment to 0. So here we can see the network that we'll be working with. This is the network for adverse outcomes. So the two parent nodes, we have intervention, treatment, severity of illness. Then we have do not treat, preference, and provider's decisions. And then we have random choice. So here we can see the network and for adverse outcomes, the two parent nodes, like we already talked about, severity of illness, intervention, treatment, and then the other nodes are do not treat, preference, provider's decision, and then random choice. We will not be focusing on random choice because it is not a common effect, so it's unrelated to the treatment and is considered a random variable or a descendant of the treatment in the network. However, it is not a parent or a parent of adverse outcomes. So the regression equation for adverse outcomes needs to include severity, DNR for do not treat, treatment, and provider's decision. The resulting equation, the regression will also have random choice at the end. So the resulting equation will have two variables which are significant and direct causes of adverse outcomes. And those two variables or nodes are treatment and severity. So on the bottom here, you can see the regression equation. So we have adverse outcomes, alpha, or the y-intercept, plus the coefficient b for treatment, coefficient for severity, which is c, coefficient for DNR, which is d, and then DNR, and then coefficient for provider, which is E, and then coefficient for random choice, which is F. Moving on, we'll do a quick recap of multivariable regression. So we have our outcome Y equals alpha, which is the y-intercept plus beta 1 plus x1 plus beta 2, x2, so on, and then the error term. So here for regression network, we want to keep in mind the network model with sequence. So just take a quick look at this. In the bottom, keep in mind covariate, treatment, mediator, and then outcomes. All right, so our first node that we're going to discuss is adverse outcomes. We've already seen the regression for that, and this is just a recap of that. So we will move on to our severity of illness and intervention, treatment, and other nodes to write regressions. All right, so let's start with the treatment intervention node for our next regression. So this node has three parents: severity of illness, do not resuscitate, DNR, do not treat preference, and provider's decision. Therefore, our lasso regression for this intervention node is treatment intervention equals alpha, which is the y-intercept, which is a constant, plus the coefficient for severity times the existence of severity. This is a significant, the This is a significant node plus C, which is the coefficient for DNR, times DNR, which is the presence of do not resuscitate order, plus D, which is the coefficient for provider, times provider. And this, all three of these, severity, DNR, and provider, are parent nodes or direct causes and therefore significant in this regression. For our next node, severity of illness or severity, we look to see if there are any parents of severity, and we don't see any. So our regression equation will be severity equals alpha or y-intercept plus C, which is the coefficient for severity. And our next node is do not treat preference or DNR. So the regression for this, because there's only one parent node or direct cause, which is severity of illness, DNR will equal alpha or the y-intercept. Again, this is a constant plus the coefficient for severity times severity. And this is the only node in this regression, and it is statistically significant. And our last node, provider's decision. Again, we don't see any parent nodes for provider's decision, so the regression equation will be alpha or y-intercept plus E, which is the coefficient for provider's decision. Moving on to part 2, we need to estimate what would happen when the intervention or treatment was not given, thus the treatment is 0 and did not occur. So I've blanked this out, the node, so no color, and it doesn't exist. So let's jump in. So here, for part 2, if the intervention treatment does not occur, we're going to discuss what happens to the network and backdoor blocking. So if our intervention is set to 0 and no treatment occurs, B times 1, we have 0. So no treatment, that's out of the network. And then we will set severity to 1, and because there are no other direct causes of the adverse outcome, then that is what our regression equation is. Adverse outcomes equals alpha, so y-intercept plus C, severity. And it's important to see here how significant nodes interact and how blocking works. And this is our statistical equation, so adverse outcomes. And yes. So in conclusion, here we see the 5 regression equations, a part of our regression network. So regression for adverse outcome, treatment intervention, DNR, severity, and provider's decisions. We see that the statistically significant variables are noted by an asterisk, and these are the direct causes for these outcomes. And lastly, if we remove one of the direct causes of adverse outcomes, we only have severity. So there was backdoor blocking. This was the only other statistically significant variable in the network. And our regression equation is adverse outcomes equals A plus C, the coefficient for severity, and presence of severity.